is about how effectively you can create resiliency and maintain that resiliency for container-based applications, right? And Appranix is at the forefront of cloud application resilience. We have been educating the customers about how they could increase their resiliency on the applications, for the applications on the cloud platforms. In particular, we are not providing these capabilities for the data center applications, and there are a host of other capabilities that we will explain. We are also now a Gartner cool vendor as of last week or so. And thank you for all the help with respect to noticing us and also giving feedback to Gartner as well. Given that, what Gartner has been saying is by 2022, a lot of applications, I don't want to quote the numbers here in terms of 75, 95, 85, or 20%, but what is clear is that the containerized applications will be in production compared to what it is today. So if that is the case, you will have to look at the capabilities of those container applications when they become mission critical or business critical. And if you look at the underlying orchestration platform, which is Kubernetes for these applications, and it has become the de facto standard, if you will. And the reason for that is multiple, including enabling the faster application delivery of container-based applications. And you have other benefits like better cloud resource control in terms of scaling, descaling, increasing or decreasing the performance, and also better utilization of the cloud infrastructure itself, meaning, instead of spinning up those virtual machines or other resources, you could pretty much have a lot more containers packed on a particular node. So that is a great benefit. I think it's not highlighted that much because the containers came from the development world where the packaging of the containers themselves are really providing great advantage. But on the other hand, when you are able to pack more and more containers on a single node, it could be a big node or a small node, but more containers, more application components running in the same node, then it becomes a lot more easier to utilize the infrastructure, especially for those companies that are suffering from pandemic-induced downtime and turn on their business side. It becomes easier and easier to kind of reduce the cost of that cloud infrastructure and make use of better utilization of that infrastructure existing, maybe the reserved instances or maybe commitments that you provide to the cloud platform when you bought the subscription from them. And then there is always the promise of cloud portability and the promise of better application resilience. In this particular webinar, we'll talk about and explore the ways of increasing the application resilience. How effectively can you do that? When we talk about container applications, that's great from the front end of the application components, but the back end of these containerized applications are still running on the virtual machines or these application components or microservices components are taking advantage of these external services. Right? It could be Bigtable or it could be RDSs. It could be other multitudes of these services that are run as platform as a service or serverless sometimes. And how do you really take advantage of that? If that is the case, when you think about the combination, we don't want to use the word hybrid application, but the combination of front-end applications running on the container platforms and the back end of these applications running as external services. Now, when you think about these two combinations, what would be your application resilience? What is that downtime cost, or if you think about are these tier one applications, if you happen to tier them in terms of the business criticality of those applications, could be tier two applications, or all the way down to the bronze application where you may not care about the applications being down for a number of hours, right? So when you think about the spectrum of application downtime, and if you look at the cost of it, it could vary depending on the type of application, the tier of application, and also your business, the criticality of that application for your business in terms of the cost of it. It's enormous in any angle you look at, right? As soon as you go and utilize these containers in production, and we use them in production, heavily, 350 plus containers running, and we're protecting our own systems, right? So we are an account on our own system, and we know the criticality of that application because we are contractually obligated to provide 99.95% of SLA to our customer because we are providing the resiliency. So when you think about from that perspective, and we can quote a number of customers that we are providing in terms of increasing their resiliency by decreasing the downtime. And we know how difficult that is if you were to utilize some of the legacy systems. So when you think about legacy systems, it could be traditional backup and recovery and DR, what we call the BCDR systems. The complexity and the struggle in terms of time, in terms of skill set to recover from cloud application downtime is enormous. That's because these old BCDR platforms, so-called, backup platforms, they used to be separate. Backup is separate from DR. Now, they are not ready for an auto-scaled environment like cloud, right? And they do not utilize the built-in capabilities of the cloud as well. Now, in fact, they introduce so much lock-in to a point where your application formats, application data storage gets converted into a proprietary data management system where you kind of give your control over to them. That is okay if you're okay with the data lock-in, but on the other hand, it also slows down the backup and recovery process, right? And hence, your ability to recover your applications really, really quickly gets affected because you are transporting the data from one system to another system, from your production environment over to this data management system. Third is that they don't provide the entire application environment protection. So which means that if you are experiencing a downtime at the moment, right now, and you are struggling to address that downtime by looking at the configurations of virtual machines, configuration of your containers, configuration of Kubernetes as such, in terms of config maps and metadata and all the connectivity between those components. If you're utilizing an older system, then you are not really getting the coverage that you need in terms of bringing back your applications really, really quickly. That's why we say go as native. In fact, build it on top of cloud platforms in terms of your resilience, in terms of the ability to bring back your systems, which means that you will have to utilize the infrastructure as code because that is a de facto standard in terms of, first of all, deploying the infrastructure itself and multitudes of other reasons, including bringing back that environment completely, including your network, including your VPC, load balancer, firewalls, gateways, routes, etc. And that means that you will have to look at many, many more resources as opposed to looking at, let's say, 100 VMs. An application for one of our customers is about close to 20 VMs, but the number of resources that they have to protect and then bring back at the time of failure is 146. So if that is the situation, how do you really think about bringing back those application components, application cloud infrastructure components really, really quickly? So what Appranix does is that it gives you that ability to like get rid of the old and legacy systems and avoid all these lock and all the problems and replace with a single integrated system delivered as a SaaS running on the cloud platform itself, which means that all your security controls, you enable two-factor authentication and integrate with your backend authorization system, authentication systems in the backend so that you can do single sign-on with two-factor authentication, including the capability to encrypt all your data storage environments with different keys in your primary environment, as well as a copy of that environment running in a different region altogether. If that is the case, how do you really make use of that entire environment and bring back, including VMs, including containers, including cloud RDS systems, firewalls, security groups, load balancers, all of that need to be brought up appropriately, which means you got to have the ability to discover all these resources, obviously, and discover them really, really quickly. You cannot afford to just discover these VMs and then storage separately and the network like legacy approaches. We have to change that legacy approach to decrease. The goal here is to make sure that you can get to that always on, potentially always on type of application if you're really thinking about providing a much better resiliency than what you have gotten used to compared to your data center, or even if you have really followed the best practices or well-architected frameworks, you will have to implement a lot of that manually, which means that you will have to understand the dependency between those cloud resources, which means that not only at that particular point in time, but also over a period of time, so they can go back in time. So downtimes happen at any point. If you are able to revert back to your previous point in time, then it's golden, because at least now you have time to go back and look at what really caused that downtime. Could have been caused by a simple bad deployment in the middle of the night to address another problem, or could be a new feature rollout by a development group that may not be aware of other changes that might be happening at the same time by another group. Or it could be a ransomware attack, plain and simple. Or it could be a regular cloud region failure that is kind of an extreme situation because of some kind of a disaster, natural disaster or something like that. Or it could be as simple as few of the services or even one of the critical services going down in one of the region of the cloud platform. Because now you have to remember that you are not operating your own dedicated data center that has been created for you by your team, handmade, all of that gold-plated components and connectivity between those physical system is no more. You are operating on a publicly shared infrastructure that's also used by your competitors maybe. So if that is the case, the potential for failure is high, which means that you will have to take care of your application resiliency as opposed to relying on the capability of some other system, or even thinking that it is a cloud platform provider's responsibility to provide that resilience. That doesn't happen. So Gartner says that cloud resilience, cloud application resilience inquiries have increased 20%, close to 20% since 2016. So the more and more customers going into the cloud, especially during this pandemic time, are looking for the capabilities to do that. And now you have to really think, so if you brought in some of those legacy approaches or legacy products, legacy tools, or even if you made do it yourself, this is one of the popular ones that are migrating now to our platform. A lot of people, when they went to the cloud, take a snapshot. You have an API, you have some initial UI provided by the cloud platform providers to initiate those snapshots. And they all turn on these snapshots and they think everything is protected. But the issue is not about turning on these snapshots. It's about how many snapshots do you gather? Have you really gone in and checked how many of those snapshots are underlying your entire application environment? Sometimes it's 25,000, sometimes it's 100,000, depending on the number of virtual machines and the backend storage and nodes that are running in the backend, depending on the services. If you calculate the cost of it, it's night and day between what we provide and what is there currently in the market with respect to backup and restore, host replication. Some of our customers have moved from a host replication system that provided the DR day in, day out reliably, but when they come to the cloud, there is no such system available. So if you compare the cost of it, it's no brainer. And you might think is it really hard to onboard and protect? No, it is not. It is as simple as, subscribe, add the policies, and recover individual resources or entire environment resources together. In fact, we love to say this, and we have proven multiple times, you can onboard, protect, and recover your applications over a coffee break, like less than 10 minutes. And we have done this many, many, many times. And so do our customers, like this #1 project management hosting a portal company. Right now, they are protecting hundreds and hundreds of virtual machines. One of the largest financial mortgage provider in the world, they are using our system to bring back their resilience, bring back their applications really, really quickly. In fact, they've been doing multiple DR tests across the region, and they compared and gave us these wonderful numbers. It used to take 48 hours to do a simple DR test. And what we call is a simple DR test. If it takes 48 hours, then it's not simple, obviously. And on the other hand, the number of team members involved in bringing back that application just for testing purposes, not even really bringing back from real downtime. You have to go through multiple tests to make sure that you can guarantee that recovery at some point in time, even if it fails for any number of reasons. And 48 hours is like an unbelievable number, right? Can you imagine over a weekend for doing a DR test, sitting with the rest of the team members, and the systems are recovering one after another, and then think about testing the database separately and the connectivity between the database and the applications, and working with the network teams, working with the storage teams. It's too complex. Appranix was able to bring back the entire environment, unlike any other, in about 37 minutes, 37 minutes. I don't know whether we call it as a night and day difference or whatnot. It's unbelievable for them, right? And then the application teams went and checked, and they went through their own verification and things like that. But it's guaranteed that the environment came up. The rest was up to the customer to verify that application was running properly or not. A similar situation with this another provider. But for today, what we are going to do is to show you how you could drastically reduce the downtime of an example e-commerce application running on container, running on cloud platform. In this particular case, we chose GCP because it's easier to demonstrate with GKE and everything. You can as well do it on any other cloud platform, AWS, Azure, whatever the cloud platform of your choice, or whatever the cloud platform that your organization has chosen for you, right, to go and do it. It's the same process, same everything. Now, in this particular case, what we are doing is that there is an e-commerce application where you can go and buy torn socks. Right? As simple as that. I mean, what is more exciting than a torn socks, right? You can go and buy multitudes of. It's a pandemic time. You're sitting and clicking all those, socks which look prettier in some ways. Of course, it is getting colder, so it's not that pretty. It's not going to be that useful. But people are. I'm just joking. All of this, right? So it's an e-commerce application where this front end of these application components are running on the containers on Kubernetes, in this particular case, GKE. And to reduce the data loss of the critical component, critical data, of this application, we are using Cloud SQL with the HA mode, which means that you can run your Cloud SQL in one of the regions of the cloud, and then you can have a read replica that is doing a synchronous replication of the data between your primary production environment. In this particular case, we are running it on GCP Central region, and it is doing asynchronous replication over to the East Coast region on the other side. So its application completely protected with respect to with respect to the data loss prevention perspective. And bunch of other components are running as platform instances. In this particular case, we are running a platform like MongoDB on the side, just to make sure that you can put all the nice pictures for the socks and things like that. That is not that critical, so we are protecting them, but the RPO could be an hour, right? Who cares? Because you're not really updating your e-commerce site with more and more socks, less than an hour. I'm just taking an example here. So you can combine these two, hybrid application, in the sense of container application for the front ends, and it needs to be scaled, it needs to be properly packaged, it should be like performance-wise, should automatically make use of the wonderful Kubernetes environment running on GKE. Why not, right? It's perfect. But on the other hand, you need to protect your applications with high availability. Going with stateful is kind of questionable yet, because people are still kind of putting together that infrastructure. Even if you went with some kind of stateful mechanism, where is the protection for it, right? It's a tough one with respect to kind of standardized mechanisms now. But even if you had it, the issue of running those nodes, all of that falls under your responsibility. That's why people are going with Cloud SQL or even serverless for RDSs, right? So in those situations, you can very easily take advantage of the entire application. So if that's the case, just imagine the application went down for any reason. The reasons that I mentioned before could be a simple application component deployment by ignorant developer. So do I call, right? I used to be a developer, so I could be very ignorant sometimes. And if that's the case, your application is done. So which means that your user, the nice red thing that is popping up, your client is losing access and completely losing revenue from a company perspective. So if that's the case, what do we do? What we are going to demonstrate is that we would bring back the entire Cloud SQL in terms of the read replica, promoted to be the primary for this application. On top of that, bring back all those instances, all the Kubernetes configurations, the config maps and the dependencies of it. And then all of the dependencies with respect to the load balancer, make sure that everything comes back from an application perspective, the connectivity is restored so that you can bring back your application. Overall, we'll have to see how fast this is so that you can reduce the downtime. And the downtime means every minute of it, it's going to cost $5K, right? On an average. Of course, it could be different depending on the criticality of the application. And not only that, you could use it for many other purposes. So what we are going to do is to showcase one of these applications running at the moment. And you can take advantage of Appranix to drastically reduce the downtime, right? Drastically reduce the downtime. That is the key thing in terms of providing application resilience. What is application resilience? I think I should have defined it. And even though it appears to be like a no-brainer, resiliency for the application from an IT perspective is how fast can you bring back your application, right? Rest is like chore. You will have to take care of the backup. You will have to you have to have the capability to bring back a virtual machine at some point in time if one virtual machine is affected and so on. So that's a backup. You'll have to have the backup. This is infrastructure speaking. You will have to have the ability to DR. That is also talking about infrastructure, right? What really matters is the ability for you to bring back your applications really, really quickly after a downtime, right? It's not about avoiding the downtime. Yes, you can use a lot of tools available out there with respect to monitoring your application resilience. You look at APM systems, or you look at your logs. You look at dashboards so that you can identify, oh, there is going to be a downtime. There's browning out. So in that case, what is the situation is that how fast you bring back that application, right, in a real disaster as well. And that is what we are going to show. So to see the demo here, I'm logging into an application that is running on containers here. I logged in. Let's refresh it, make sure that it's all perfect. So I have about 267, orders on my cart, and you have like I told you, I promised you about the tone socks. Of course, you have beautiful socks as well, colorful socks. People wear this kind of nice ones. I'd love to get these comfy socks for the cold weather here. It's already like 37 degrees Fahrenheit in this area. So what we are going to do is that, we are going to simulate this to a point where I have automated, adding more socks to my shopping cart. So if I click there, let's reduce the speed a little bit, and then kickstart this buying the sock activity. Let it buy, and then if you look at the application running here, it's going to add more and more socks in the backend, right? Just to make sure that it's adding more and more, so that 68, and there you go. The automation has started. It's simulating to an extent people buying the sock continuously. In that case, my application is running somewhere. So that application is running on the central region of the cloud, and you can see the Kubernetes node GKE nodes, powering the several components of this application. I will show you in a moment. And then you have a couple of these VMs running MongoDB type of document management system, and there is this SQL running in two different regions. One is basically a read replica, as I mentioned. This is the production instance. All of that is front-ended by the container application running on GKE. So if you look at the GKE infrastructure, you have many parts and many services running, and you can see the parts that are powered on here. So if you look at across the board, it's a complex application. The complex application could be visualized like this. You have several of these applications dynamically changing, because the automation is kicking off, adding more and more socks and so on. So if we think about the containers, and the pods, they're all functioning perfectly. So what we are going to do, we are going to introduce a downtime, simulate the downtime, right? So what let's see where I am. I see it's the container, and I'm going to introduce a disaster here. So let's see if I can introduce a disaster. I have to just authorize this one, and it's going to take down the application. So let's see if we can refresh this. It's spinning, right? It's going to be offline, and then everything is down. So it will take a few seconds, maybe a minute to catch up for the browser, and there you go. So it is done. Now you're in a panic mode. This is where Appranix comes in. Appranix gives you that application resiliency. So if you were to onboard, all you have to do is Appranix container application resiliency. Call it as a resiliency. Right? You have built into GCP marketplace, same as on the AWS marketplace. You onboard your application, subscribe and onboard your application. You can configure right in your GKE environment. Once you do that, you get an email to log in, and you simply add your Kubernetes connection. You simply say your cluster name and the description, and add the controller information to your GKE environment. That's it. It's completely automated, and you can start with your assemblies. What we call as an assembly is basically an assembly of cloud resources. In this particular case, it's an assembly of your Kubernetes environment running bunch of namespaces as well as external service assembly running your Cloud SQL, as well as bunch of VMs running the order database as well. So it's basically the SOX images are stored in this particular one, whereas Cloud SQL is the main database that's protecting your main critical data with respect to shopping cart and things like that. So now all of them are running, all of them are protected. You can put a policy in terms of daily policy or an hourly policy here. This will be automatically kicked off by the container side of the equation. So if you look at the policies here, it's protecting every hour, but in the backend, Cloud SQL is replicating every second. It's basically an asynchronous replication. So everything else is protected by an hour. Now, you are in a panic mode. So what we are going to do is to recover the entire instance, right? So I go in at a particular point in time at 1 o'clock. So I'm going to do a quick failover of this environment. So let's do the failover. I'm going to select the cluster. This is my production cluster, but we are recovering in another cluster. So we are going to the East Coast of the cluster. You have the external services to recover, obviously, that external SOC shop databases, and also fail over the Cloud SQL instance and recover in another region of the cloud. In this particular case, it's East. So if you look at the VM instances that have been running, the VM instance could be running. The cluster nodes could be running by introduce a simulation. So it's all running in the central region here, right? We are going to switch over to the West Coast. So if you look at the central region, since we simulated that environment, you can see the pods are down. All the pods are gone. And if you look at the East Coast where we are going to fail over, no other pods. The basic pilot-like Kubernetes GKE environment is running. So now what we are going to do is to bring back that application from the downtime that we are experiencing. Every minute is costly. So you might say that, Govind, please stop talking, do something about it, right? And what we are going to do is to bring back that application with that click. So we initiated that. So we haven't initiated. We are going to just initiate that, which means that the recovery has started. So you can see the recovery is running now. And if you think about the back end of the recovery here, if you go to the timeline, it automatically kicks off an on-demand recovery for that environment. So if you look at that detail, if you go into the details of the recovery, you can see the recovery logs. So you can have the audit information of what really happened with respect to recovery. I'm recovering from a downtime. I'm recovering the entire firewalls, the disks and subnets and whatnot. But I should be using some guaranteed system. So that guaranteed system is the infrastructure as code. So somebody has to really kind of understand all the dependencies and key in all the infrastructure as code automatically for me, so that I am guaranteed to recover my systems, because there is no guarantee in a public cloud. How do you know? It's all shared infrastructure. So if you look at this level of code, somebody should have written that code at a particular point in time when my application really, really failed. So if you look at the amount of code there, it's decent. I wouldn't say it's complex or anything. You can see it's about 750 lines of code. And if writing that lines of code is not a problem. It's just another language, deployment manager language, simple DSL or YAML file. And the problem is not. The problem is about understanding the dependencies, understanding the metadata, understanding the configuration at the time of failure is a problem. So even if you did all the snapshots, you created those snapshots by automatically scripting it, and the snapshots are already running. Of course, you'll have to now go and locate those snapshots, appropriate snapshot at that particular point in time, and attach them to your instances. Bring back those instances. So great. Even if you brought back those instances, what's the instant configuration with respect to ports? What's my configuration with respect to load balancer? What's my configuration with respect to GKE? What's my configuration with respect to external services connected from the GKE to my platform in the backend, right? So data is one set of problem. Of course, you have to back up, you have to recover. That's all taken for granted, right? That's all old days. Yes, I have to back up. What do you mean? It's a chore. I back it up all the time. Great. If you are worried about just backup, not a problem. You snapshot it and tell the business that, oh, I backed up, not a problem. But the issue is not the backup. The issue is not the disaster recovery, right? This is a concept. So far in the legacy world, in the data center, and it was just a concept. Nobody really ran the disaster recovery, right? Recovery tests, rather. No, they don't test. It's too complex. Right? If it takes 48 hours, who runs those things? So you may not have even recovered your VMs and tested your backups. Forget about the disaster recovery test. So if that's the case, when the real downtime happens, it doesn't have to happen all the time. The pandemic doesn't have to happen all the time. It has to happen once in 100 years, literally, right? But it happens, and you need to be prepared for it, right? You got to have a system to do it, which means that you need to make use of proven and supported mechanism for it, which is the infrastructure as code natively written for that particular cloud provider. So it's cloud native infrastructure as code automatically written by Appranix with the dependencies automatically figured out, and also the order in which those services need to bring back, right? All of that has to be brought back properly. So how do you really kind of explain all of that? If you were to bring in a smartest cloud operations person, he can code it up. He will understand how to code up for GCP. That's perfect, nice. But he will ask you a number of questions with respect to what's my port? What was my configuration at the time of failure? And that is an issue. So think about application resilience and application resilience to reduce your downtime. How fast can you come back from the failure defines the resiliency, right? How fast can your application come back from the downtime defines how perfect are you in terms of providing that application, cloud application resilience, right? And that is a complex activity to a point where you should be able to recover all of that. So all the recovered resources, 2 minutes and 37 seconds for the back end of the resources. So if you think about cloud platform, if I go to US East, I can see same number of instances being brought up. So you just look at the US Central, right, as well as US East. You cannot obviously combine those two. So Central one, and you can you do the US East as well. Both are not running in the same places, so it's either or. Now, the services on this side, let's see if those services have come up. Perfect. You can see the East Coast services have come up because we induced that central region services. We simulated the disaster over there by zeroing out all the parts, right, by undeploying the containers, and Kubernetes automatically took care of the rest as the application failed. So what we are going to do is to just make sure that we can bring back the DNS. So I think I have a script for that, DNS, update DNS. So I'm going to just say update the DNS just to make sure that I'm updating the DNS to point to the new environment as well. So if you think about all those instances, if you look at the Cloud SQL here, and Cloud SQL should have been promoted from, there you go. So it was a read replica. When you have a read replica, GCP shows that as a kind of a tree-like structure. You saw that before. So the Cloud SQL is still, and we didn't really kind of induce the disaster to a point where kill everything, right? We didn't do that. So it's still running on the central region. But the key thing is that how the application has come back by bringing back that Cloud SQL read replica and promoted that to be the master here. So if you look at, there was no activity. for the replica, smaller activity with respect to just getting the data from the production system over a period of time. And now, we kickstarted that part. So we added more and more. If you look at this part here, there was a bump here because there was more data coming in because I started the replication from the production environment over to the replica when I kickstarted the automation using automatically adding the socks to my shopping cart. So that's where that clear bump is. And the services on the recovery side, if you look at the East Coast, as I mentioned, look at the services phase. If you go to carts, you will see the service configuration. So if you look at all these configurations, you can see the application is kickstarting automatically. So if you look at the regular YAML files are all retained. So if you had the YAML Kubernetes specs to be specific, all of that are back here, right? All your configurations. Think about that. All your configurations that you worked hard to kind of preserve. Now, if you think about bringing back that configuration over to the East Coast from the central region, just because my application failed, I mean, this is complex with respect to not only thinking about from a Kubernetes perspective, but also from an external service perspective. It becomes too hard for a single SRE or even a team of SREs to figure out how to bring back these applications, right? So why not just offload that to a service that is built right into the GCP marketplace or AWS marketplace, right? So let's see if that application has kicked off. There you go. The application is back. If you log in with that, I don't even know. I think we stopped at 272, and let's see what that really is. Wow, it's 303. So I didn't even know that, that the backend automation really kicked up more and more buying the socks in the backend. And the revenue loss, if I lost it, would have been like right here, the number of minutes, just an approximate number, obviously, example numbers. It's about highlighting, whether my application could be brought back, whether my downtime could be drastically reduced so that, I can avoid all that problems of downtime and the cost associated with it. I mean, this is enormous, depending on the application type, obviously. And, you don't want to do that. Not only that, think about the reputation for your company, for your team, IT team in the backend. Delta went through a downtime. It costed me $150 million, right? So it's the large system, small system. Facebook went through a downtime. Can you imagine Facebook going down? That cost them $25 million some time ago, right? And you might have seen Gmail going down, the entire G Suite going down at some point, but they all come back. But the issue is that they know how to operate the cloud infrastructure because they have been running cloud infrastructure. But for normal application developers and the organizations that are going to the cloud for the first time or even running for a few years, it only gets complex every day, right? And that's where we help you in terms of achieving that application resilience by bringing those applications back quickly from the downtime. That's about the resilience that you can provide. So let me stop here. I've talked a ton and see if there are questions. You could key in. I think Mikey has been active in terms of providing the question and answers. Feel free to ask questions. Mike will be able to answer, or I will be able to answer really quickly. Any questions so far? And it is available for you to quickly add to your system from right from the Google Console or AWS. It's free to add. Any questions so far? And the entire webinar has been recorded, so you can go back and if you could highlight to other team members within your organization or spread it out over your social connection, we will really appreciate it. And if there are no more questions, thank you for joining us again. Really appreciate the time. Hopefully this was very useful for you. And if you have any additional feature requests and things like that, we are really, really fast in terms of adding because we are a SaaS company. So we change a system almost like 6 times per day. So we'll be happy to help you with respect to any additional capabilities as well. So with that, thank you.